When the potential difference across the filament of a bulb is 100 volts, the current through it is found to be 2 amperes. Find the resistance of the filament. So we are asked to calculate what the resistance, which we'll call as R, of the filament is. This is what we need to find. And what we are given is the potential difference across the filament of the bulb is 100 volts. So if you just draw this, let's draw what's given to us. So imagine here's the filament. Here's the filament. We are given the potential difference across the filament of the bulb is 100 volts. So the potential difference across this end, this is 100 volts. So V is 100. And the current through it is found to be 2 amperes. So there's a current running through it, and this current is 2 amps. So I is 2 amps. So given this, we need to find what the resistance of the filament is. So we need a connection between voltage, current, and resistance. And this connection is what we call Ohm's law. So Ohm's law tells us that V should be equal to I times R. So if we plug in the values over here, we can now calculate the value of R. So pause the video and see if you can do this yourself now. All right, so let's plug in. We know the voltage is 100 volts, so this is 100 volts. That's going to be the current, which is 2 amps. This is 2 amps times the resistance, which we don't know. So to calculate the resistance, let's divide on both sides by 2 amps. The 2 amps cancel over here. And from this, we get R equals 100 volts divided by 2 amps. 100 by 2 is 50. And so we'll get the resistance to be 50 volts per ampere. And volts per ampere is what we often call ohms. So we'll say the resistance is 50 ohms. So there we have it. The resistance of the filament is 50 ohms. Okay, let's try one more. A current of 6 amperes flows through the heating element of an iron box. If the resistance of the element is 30 ohms, find the potential difference across it. So great idea to pause the video and first see if you can gather what is asked, write down what the data is, and try and solve this problem yourself. So pause the video and try and do that first, and then we'll solve it. All right, let's do. Okay, let's do it. We are asked to find the potential difference across the element. So potential difference is what we need to find, V. And what we are given is the current of 6 amps flows through the heating element. So if we draw, so let's say this is our heating element. I'm just going to draw it as a resistor. The current through it is 6 amps. And we are given the resistance of the element is 30 ohms. So this is 30 ohms. So I is given to be 6 amps. And R is given to be 30 ohms. So we need, again, a connection between V, I, and R. No surprise, we're again going to use Ohm's law. We already just saw that Ohm's law says V is I times R. V equals IR. That's Ohm's law. And we can now plug in and get the answer. So if you haven't done it already, again, good time to pause the video and see if you can get the answer yourself now. All right, let's do this. So V is going to be I, that's 6 amps, times R, which is 30 ohms. So V is going to be 6 times 3, it's 180. The unit looks like ampere ohms. Ampere ohms. But if you look at it, ampere ohms is actually what volt is. So we already know the unit of potential difference is volt, right? And the reason it turns out to be volt is because ohms is actually volts per ampere, which we just discussed in the previous question, right? And so the ampere cancels and you end up with volts. So we don't have to worry too much about the units. The current will always be in amps, the voltage will always be in volts, and the resistance will always be in ohms. So out of the three things, voltage, current, and resistance, when any two of them are given and we need to find the third one, we always use Ohm's law.